solving systems that involve decimals or fractions. So if we want to solve a system that involves decimals, we want to get rid of the decimals. And the easiest way to do that, in this case, everything is a tenth, so we'll multiply through by 10, and this will become 5x plus 3y is equal to 2. And multiplying this equation by 10, we will get 3x minus 6y is equal to negative 30. And the important thing here really is especially making sure that the right-hand side gets multiplied by 10. A lot of times we remember to get rid of the decimals on the left-hand side, we forget about the right-hand side. So this will be my new equation 1 and equation 2. We will solve this. Slide this down. And the easiest way would be to multiply equation number 1 by 2 to get these to be 6y, and then to subtract. So 2 times equation 1 gives me 10x plus 6y is equal to 4. And equation 2 is 3x minus 6y is equal to negative 30. And when I add these, I get 13x is equal to, this is gone, right, and we get negative 26. So x is equal to negative 2. We'll then substitute that into either one of the, I'm going to go with this because that's a smaller number. So we're going to substitute negative 2 for x in number 1. And I'm not going back to one of these originals here. I'm pretty confident these are correct. But when I go to verify, I'll check it back in the originals. So we get 5 times negative 2 plus 3y equals 2. Negative 10 plus 3y is equal to 2. 3y is equal to 12. And y is equal to 4, giving me a solution of negative 2 comma 4. And, you know, we can do a formal verification of that or not. So negative 2 times 0.5 is negative 1 plus 1.2, and that will equal 0.2. And this will give me negative 0.6 minus 2.4, which will give us negative 3. So that works out in that case. B, we have fractions. Now, anytime we have an equation with fractions, the idea is we get rid of the fractions. And to do that, we know that we need to multiply by the lowest common multiple, right? The highest number, or the smallest number that both of these will go into. So in this case, that's 6. So we're going to multiply by 6. So that'll give me 3x plus 4y equals negative 12, right? Because the 2 goes into the 6 3 times, giving you 3x. Right, so just, and you know, if we put a 6 there over 1, that's a 2. 2 times 2y is 4y, and negative 2 times 6 is negative 12. And here we're going to have to multiply by 12, so that'll give me 12y is equal to 3x minus 20, right, because 3 goes into 12 4 times. And, well, you know, if we move this over here, then this will become negative 3x plus 12y equals negative 20. And we can put that together with this guy, and then using elimination, we'll just add these. Right, so here, this was our first shot just at getting rid of the denominators. We now have this equation rearranged from here. We'll take the 3x plus 4y equals negative 12. We're going to add these two guys. I get 16y. And that'll be negative 32. And so y is equal to negative 2. And then we substitute, and we'll go into one of these guys, and we'll go back and we'll check here. Let's just clean that up so that I can check in there. So let's go to this one here, right? So 3x plus 4y equals negative 12. 3x plus 4 times negative 2 equals negative 12. 3x minus 8 is negative 12. 3x is equal to, I'm going to add 8, negative 4, and x is equal to negative 4/3. Okay, let's try that out. I'll be a little more formal in checking this. So, let's move down here. So I've got y. Let's do this. Left side is y. Right side is 1/4 x minus 5/3. So the y value is negative 2. I have 1/4 times negative 4/3 minus 5/3. So the 4's cancel here. Gives me negative 1/3 minus 5/3, which is negative 6/3, which is negative 2. I'm a little sloppy with the tablet. So that checks. And we have the left side is x over 2. And the right side is, left side is x over 2 plus 2y over 3 okay, and the right side is equal to negative 2. So x over negative 4/3 hang on, x is negative 4/3. So negative 4/3 over 2 plus 2 times negative 2 over 3. Okay, so negative 4/3 divided by 2 is like negative 4/3 times a half, and this will be minus 4/3. That cancels, so we get negative 2/3 minus 4/3, which is negative 6/3, which is negative 2. Ding. So that checks. So it's all good. And we now have this one. 2/3 m minus 1/2 n, and we're changing the second equation on your worksheet to this. So there's a change from what's on your worksheet. And our first thing really that we're going to do is we're going to go through and multiply this out by a half. So that'll give me m plus n over 2 equals negative 4. And you notice that the half in this case does not multiply the right-hand side. It's only a half times this, so we're going to do that first. Then to get rid of the denominator, we're going to multiply by 2. And we'll multiply this whole thing, right? Which will now become 2m plus n is equal to negative 8. Okay, we don't like fractions, right? And we're going to get rid of this here by multiplying this by 6. So 3 goes into 6 twice, giving me 2 times 2m, or 4m. The 2 goes into the 6 3 times. Remember, because this 6 multiplies this, then it multiplies this, then it multiplies this. So this will be minus 3n equals 24. Now, this can be solved. Let's call that 1 and call that 2. So we're going to solve 2 for n, giving us n is equal to negative 2m minus 8. We're going to substitute. Sorry, this is a borrowed tablet, and it's like somebody spilled something on it. we're going to substitute negative 2m minus 8 for n in number 1. So number 1 is 4m minus 3. Now instead of instead of n, we're going to put in negative 2m minus 8, and that equals 24. 4m plus, minus times a minus, plus 6m plus 24 equals 24. 10m equals 0, so m is 0. And then n, well, if m is 0, then n is equal to negative 2 times 0 minus 8, so n is negative 8. And so in alphabetical order, mn is 0, negative 8. And, you know, I think we can just verify this. Let me clean up a bit here. Verify by plugging in. So the m is gone, right? So we get negative a half times negative 8, which is positive 4. And this is basically gone, right? It's a 0. So we have negative 8, and a half of negative 8 is negative 4. So it checks in both, and that is the solution. And so, you know, don't panic when you get 10m equals 0. That's perfectly allowable. It just means that m is equal to 0. And we've got a little one for you to do here. Solve each system of equations below using multiplication with the addition method. And again, it's just, you know, make sure that you expand it out. Right, and then, yeah, I don't really care if you use substitution method. I mean, but you can multiply this, right, and you'll get like 6x plus 2y equals 20, and you'll solve that system. And don't do it in here. Do it on a separate sheet of paper where you've got some room. More word problems, or actually some word problems. An alloy is a mixture of metals. An artist was commissioned to make a 100-gram bracelet with a 50% silver alloy. He has a 60% silver alloy and a 35% silver alloy to work with. What is the mass of each alloy needed to produce the desired alloy? So in other words, you know, if we melt down some of the 60% and some of the 35% and mix that together, you know, we can get any strength we want between 60% and 35. We can't go above 60% because, you know, this would be diluting it, and we can't go below 35% because that's the lowest we've got, but we can go anywhere in between, and 50% is in between. So usually, you know, we need to define our variables, and we could say let x and y, but in these types of questions, it's best to make a little table of values, right? Make a table, mass of alloy. And what we've got to work with is we've got the 60% alloy, and we say we're going to take x grams of that, and we've got the 35% alloy, and we'll take y grams of that, and the 50% alloy, what we want to end up with, well, we want to end up with 100 grams of that. And, well, how much silver will we actually have? So mass of silver. So the 60% alloy, so 60% of x is 0.6x. And 35% of y, because 35% of this is silver, is 0.35 y. And if you have a 50% alloy, then you have 0.5 times 100, which is 50, so 50 grams. And you notice by doing the table, we also get our equations here, right? So we have our two equations. X plus y is equal to 100, and 0.6x plus 0.35y is equal to 50. Right? And so x is our mass of alloy, right? How much of the 60% silver alloy, and y is how much of the 35% silver alloy. Okay, anyways, we want to solve this. Well, if we multiply this, you know, let's see, what can we do with these? I could straight solve, for x or y, and then use substitution, just putting in here. I could multiply this by 10 or 100 to get rid of the decimals. Why don't we do that? Let's just get rid of the decimals, so multiply by. So we'll get 60x, let's just say times 100, plus 35y is equal to 5,000. And here, what do we want to do? Well, let's go x is equal to 100 minus y. And then we'll substitute. So 60 times 100 minus y plus 35y is equal to 5,000. So 6,000 minus 60y plus 35y is equal to 5,000. So this will be negative 25y, and this will be negative 1,000. And so negative 1,000 divided by negative 25 is 40. And if y is 40, then x is kind of obviously 60, right? Let's pop up here. And so x is 100 minus 40. X is 60. I'm showing a little less detail in my work here, right? But I think we can still follow what's going on here, right? I mean, that's solve. So let's just write in here, solve for x. Right, and that's saying let's multiply by 100, and then here we're substitution, so substitute. And then solve, and then we answer the question, right? So what is the mass of each ally? So he needs, he needs 60 grams of the 60% silver alloy, and 40 grams of the 35% silver alloy. Now, with any word problem, what I like to do when I check it is just forget everything down here and just go back to the beginning. Say, so if I take 60 grams and 40 grams, I will get a 100 grams. Okay. If I have 60 grams of the 60% alloy, that means that I have 36 grams of silver. And 40 grams of the 35% alloy means that I have 40, 35 is 14 grams of silver, and 36 and 14 is 50 grams of silver, which is the grams of silver that will be in a 50% silver alloy. Okay, so all makes sense, everything checks, and we're good to go. Distance, speed, time questions. Very common type of question is a distance, speed, time. Always, always, always distance, speed, time, do a table. So, let's do a distance, speed, time table. Okay, so 3 columns, one for distance, one for speed, one for time, and keeping in mind that the relation between them is that distance is equal to speed times time. We got a patrol boat, 5 hours to travel up the river against a current, and 3 hours for the return trip with a current. And we need to find the speed of the boat in still water and the speed of the current. So we got a boat that's going upriver, and then it's coming back downriver. The distance in both directions is 60 kilometers. 60 kilometers upriver, 60 downriver. The speed up the river, when you're going up the river, you're going against a current. So you've got the speed of the boat, which we will call V, and the speed of the current. So it's V minus C, right? If the boat's going 50 kilometers an hour and the current is 10, then it's going 50 minus 10, or 40. And going downriver, it's got that assist, so it's v plus c, right? So in this case, v is the velocity of the boat in still water. We might even want to write that over here, v, speed of boat in still water. And c, the speed of the current. And the amount of time it takes. Well, it takes 5 hours to go up river, and it takes 3 hours to come down river. Whoops, I didn't mean to add that little stroke there. And we know that distance is equal to speed times time, right? So 60 is equal to 5 times v minus c, and 60 is equal to 3 times v plus c. Now, you could multiply this 5 out, right? But if you do that, we'll get 5v minus 5c, and then down here we'll get 3v plus 3c, and instead we could say, wait a sec, I can divide both sides by 5, giving me 12 is equal to v minus c, and here I get 20 is equal to v plus c, and you know, that's an ideal elimination, right? Because now we're just going to add. So we get 32 is equal to 2v, and v is equal to 16. And then we go to one of these guys. So 12 is equal to 16 minus c, and c is equal to 4. And then we state that, right? So the speed of the boat in still water is 16, what are we in kilometers per hour, and the speed of the current is 4 kilometers per hour. I'm running out of tablet. Okay, now if I want to check that, I just go right back, forget everything that's here. It took it 5 hours to travel 60 kilometers up a river against the current. So if I'm saying that the speed of the boat in still water is 16, and it's going against a current of 4, then that's 12, and 5 times 12 is 60. And 3 hours for the return trip. Well, if I'm saying the speed is 16 and the current is 4, then together that's 20, and 20 times 3 gives you 60, right? 20 kilometers an hour times 3 hours. So, works. Another one, another distance speed time, because you're going to see a lot of distance speed time. Kareem drove 650 kilometers to visit a friend. For part of the trip, he averaged a speed of 80 kilometers an hour. For the rest of the trip, which took twice as long, he traveled an average speed of 90 kilometers per hour. Okay, so again, distance speed time. Part 1, let's just say this is part 1. Part 2. So we'll call this distance x, and we'll call this distance, part of the trip we averaged a speed of 80 kilometers. We'll call this y. Speed here is 80. Speed here is 90. And time. Time is distance divided by speed. Right? So if distance, is equal to speed times time, then time is equal to distance over speed. And 80 over x, 90 over y, and what do we got? Let's say the total. So the total distance was 650, and the rest of the trip, part of the trip. And what do we know about the times? The rest of the trip was twice as long. Okay, so let's do this. We got x plus y is equal to 650. Whoops. And we know that this time is twice this time. Right, so that 90 over y is equal to 2 times 80 over x. So 90 over y is equal to 160 over x. And from this here, we'll go x is equal to 650 minus y. And we're going to go down to here, and we're going to substitute. So instead of x, we'll write 650 minus y. We're going to cross multiply these, right? So 90 times 650 minus y is equal to 160 y. Sorry, running out of tablet. 90 times 650. I need to get a calculator. Okay, so that is 58,500 minus 90y is 160y. Move the 90y over. So 58,500 is equal to 250y. So get calculator out, divide by 250. And y is equal to 234. And x, I wonder what they're asking us in here for part of the trip. X will be 650 minus 234, which is 650 minus 234, 416. So the question which was left unanswered, I guess, is how much, what were the times and the distances. So he traveled. So what was this time? It was 80 divided by 416. Divided by 416, which is 80 divided by 416. Okay, wait. I think I got it backwards. Time is distance over speed. Oh, cripes. I wrote this wrong. It's x over 80. And y over 90. Quick, resolve. I'll leave this in with maybe a note about you could skip ahead because I messed this up. Okay, so what was the other one? We know part 2, so that y over 90. Part of the trip for the rest of the trip, which took twice as long. So this time here is double this time here. So it's 2 times x over 80. So y over 90 is x over 40. So 40y is equal to 90x, and y is equal to 9/4 x, right? Just divide both. And then, yeah, forget this. Let's just go back into here. So we've got x plus 9/4 x is 650. This will be 4/4. Thirteen over 4x is 650. Multiply by 4. 13x is 4 times 650. 2600. And x is 200. So go back here. This is 200. This is 450. This is 200 divided by 80, which is 200 divided by 80 is 2.5. And this is 450 divided by 90, which is 5. And so that fits, right? We have 200 and 450 is 650, and we've got 2.5 hours and 5 hours, and this part is double this part. And, you know, oops, sorry about that little mess up, but hey, sometimes that's the way we do math. We mess things up, and then we realize that we made a mistake, and then we fix it. And so I'll put a little annotation in here saying, hey, this is kind of messed up, and if you want to skip to the where it gets corrected, then skip to this time in the video. And that kind of ends our more word problems, right? But I guess all those didn't ask anything but the first part of the trip. The first part of the trip. At 80 kilometers per hour was 200 kilometers and took 2.5 hours. The second part of the trip was 450 kilometers and took 5 hours. And fits in with the explanation of what's up here. And we're done.